Hello everyone, good morning to all of you. Today our department head Dr. P. Subrahmanyam garu, who is retired principal of Subrahmanyam College, has came to our studio to teach us some basic chemistry. You please follow this basic chemistry to enhance your funda knowledge. I hand over the mic to Dr. Subrahmanyam garu.
Thank you, Dr. VRAO, for inviting me to your studio and having given me an opportunity to talk about some basic chemistry. I start with some 3 equations which I have written on the board. One is our food, glucose prepared by plants. Second one is a combustion reaction, which is a basic reaction for our energy. And the third equation is about our ionic structures. Basically, chemistry deals with change of one substance into another substance. That is a chemical change. Usually, chemical change also accompanied by physical changes also. Now, our chemistry deals with both large aggregate of molecules, atoms, ions, but also at the nano level smaller aggregates of atoms, molecules and ions. So, let us begin. What do we mean by an atom, a molecule or an ion, which are our basic units in study of chemistry. Now, in the first equation, I have put 2 substances on left hand side and 2 substances on right hand side. I call them as RHS and LHS. Now, carbon dioxide is represented as CO2, water as H2O, a glucose molecule, a glucose is represented as C6H12O6 and oxygen as O2. All these things are in the molecular form. Similarly, in second equation also, this one is called marsh gas or methane and this is oxygen and we are getting carbon dioxide and water. Now, these are also in molecular form. Look into the third equation, sodium chloride. I put Na plus and Cl minus as our division of sodium chloride. I call this as a formula and Na plus as a cation and Cl minus as anion. This plus and minus represent charges on sodium and chlorine respectively. Now, you observe sodium plus electron is equal to sodium atom. Chloride minus electron is equal to chlorine atom. 2 chlorine atoms combine to form chlorine molecule. This process we can do using electrical energy inside an electrolytic cell. Process is called electrolysis. We can obtain sodium at an electrode called cathode and chlorine at an electrode called anode. Now, as a representation of atoms, molecules and ions, I have taken these 3 examples. The first example is about our food. The second example is about our energy, mechanical energy, and the third is about a process which involves ions. These reactions involve energy changes also, which we can talk later. Our present aim is to speak about basic units which we deal with in chemistry. Now, what is an atom? How to identify an atom? An atom can be identified by two numbers. One number is called atomic number, the other number is called mass number. Atomic number is number of protons present in the nucleus of an atom. Electrons must be equal to this number, that is called atomic number. For example, atomic number of hydrogen is 1. That means hydrogen nucleus contains 1 proton, and around hydrogen nucleus we have 1 electron, which is called extranuclear electron. Say atomic number of carbon is 6. That means an atom of carbon nucleus contains 6 protons, and around carbon nucleus we have 6 electrons. Right. Similarly, we have the atoms of other elements. So, identify an atom by a number, that is called atomic number. Then let us go for a mass number. Mass number tells us about number of protons and neutrons present in a nucleus of an atom. Protons and neutrons together called nucleons. So, mass number is number of nucleons present in an atom. Now, let us see hydrogen, deuterium and tritium. These three are elements of hydrogen only, whereas they differ in mass number, but atomic number remains same. Therefore, they are called isotopes. Why this name? Isotopes means they occupy same position in an arrangement of elements called periodic table. So, periodic table is our next topic of discussion. For the present being, simply assume a number indicates an element. So, number 30 indicates zinc, number 92 indicates say uranium, number 79 indicates gold, number 10 indicates neon. Remember some numbers. Number 2 indicates helium, number 10 indicates neon, number 18 indicates argon, number 36 indicates krypton, number 54 indicates xenon, number 86 indicates radon. What do you mean by atomic number 86? That represents an element called radon. The radon nucleus contains 86 protons, and around radon nucleus we have 86 electrons. See? So, one number if you remember, that represents one element. Then what about mass number? Mass number is number of protons and neutrons in the nucleus. In hydrogen atom we have only one proton, that is called protium. In deuterium we have one proton, one neutron in the nucleus. In tritium we have one proton and two neutrons. Separate names are given for the so called isotopes of hydrogen. For other elements we simply put mass number and atomic number to indicate an isotope. For example, I say C13, C14, C15. Similarly, O16, O17, O18. These upper numbers, they represent mass number. The moment you put C, it is nothing but carbon, atomic number is fixed by 6. So, you need not put any number here, but for the sake of clarity, you can also put the number 6 like this. Okay. Now, these isotopes have a particular ratio in nature. Isotopic abundance is fixed in nature. For example, if you take chlorine molecule or chlorine atom, we have two chlorine isotopes, Cl, tell me the number, chlorine isotopes, Cl35, Cl37. Its atomic number is 17. That means 35 chlorine contains 18 neutrons and 17 protons, whereas 37 chlorine contains 20 neutrons and 17 protons. Now, the ratio of 35 and 37 chlorine are fixed in nature, approximately in the ratio 3:1. You can calculate the average number called average atomic weight by knowing the proportions of these two elements in the ratio 3:1. You can work out. It works out to be around 35.5. So, an average chlorine atomic weight can be taken as 35.5. In another way, this number also indicates the number of times an atom of chlorine, an average atom of chlorine is heavier than a single hydrogen atom, which is also approximately equal to 1/12 of carbon 12, 1/16 of O16. That is an average scale of atomic weights, a standard scales of atomic weights. Now, let us define a molecule. Molecule could be a combination of atoms of the same element or different elements combined together in a fixed ratio. We call them as stoichiometric ratio. Say, a molecule of glucose contains 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms combined in a fixed proportion by weight. It is very easy to get this fixed proportion from the molecular formula, because we know the atomic weight of carbon is 12, the atomic weight of hydrogen is 1 approximately, the atomic weight of oxygen is 16. So, 6 into 12, 72, 12 into 1, 12 and 6 into 16, 96. Total works out to be 180. So, proportion is 72 parts by weight of carbon, 12 parts by weight of hydrogen and 96 parts by weight of oxygen. That ratio is fixed in all glucose molecules. In all glucose molecules, this ratio is fixed. Take for example carbon dioxide. The atomic weight of carbon is 12 and we have 2 oxygen atoms, 32. 32 plus 12 is equal to 44. So, out of 44 parts by weight of carbon dioxide, we have 12 parts by weight of carbon and 32 parts by weight of oxygen. So, that ratio is fixed in all carbon dioxide molecules. Similarly, we can work out the constant proportions of these elements present in the compound, present in the molecules. Right. What about ions? Ions represent charged particles. We can say ion, we can define ion as atom or group of atoms having residual charge. Atom or group of atoms having residual charge. What do you mean by residual charge? We know atomic number tells us number of protons present in the nucleus. If this number equal to number of electrons present outside the nucleus, we say the atom is neutral. If the number is varied by chemical means, either by the loss of electrons or by the gain of electrons, then the unbalanced charge is called residual charge. In case of sodium ion, Na plus, there are 11 protons in the nucleus and 10 electrons only outside the nucleus. One positive charge is left unbalanced, which I represent as plus. Okay? What about chloride ion? There are 17 protons in the nucleus of chlorine, whereas 18 electrons outside the nucleus. One electron charge is unbalanced, so I represent minus charge here. So, cations are those atoms or even group of atoms having positive charge, residual positive charge. Anions are those atoms or groups of atoms having residual negative charge. So, in chemistry, we always talk about atoms, molecules and ions. In a molecule, if you count the total number of atoms present, it is called atomicity. Say for example, in the glucose, the atomicity is 6 plus 12, 18 plus 6, 24. 24 is the atomicity of glucose. 3 is the atomicity of carbon dioxide. 3 is the atomicity of water. Now, we call them as diatomic, triatomic, tetraatomic, polyatomic molecules. And the atoms could be of same element. Say hydrogen diatomic H2, oxygen diatomic O2, chlorine diatomic Cl2. We call them as homogeneous diatomic molecules. If you take a molecule like say HCl, it is a diatomic molecule, but I call it as heterogeneous diatomic molecules. And mind you, in organic chemistry, thousands and thousands of carbon atoms, hydrogen atoms, oxygen atoms, nitrogen atoms can be present in a big molecule called macromolecule. Or we can have large molecular weight compounds called polymers, where the molecular weight runs into millions also. That means a molecule of a polymer is million times heavier than a single hydrogen atom. Something like that. To the tune of millions also, we have molecular weights. Oh, yes. Our chemical problem is, why should atoms combine to form molecules and ions? Why? So, for that we need to know the electronic configuration of the elements. What do you mean by electronic configuration of the elements? The arrangement of electrons around the nucleus in various energy levels. And what are energy levels and how we are going to arrange electrons in these various energy levels, factors affecting these arrangements, etc., we can discuss in our next video. Thank you, Venkateswara Rao, for giving me the opportunity of talking to you in your studio. Thank you.